The idea behind these infinite polynomial power series is that we can add terms as we go and we can add them infinitely to make them better and better. And so here I've drawn in the our red graph here is the exponential function. Okay, so we can see that we have the exponential function in red. And we have this, in purple, we have this quadratic polynomial expansion of the series for e to the x. And as we increase the number of terms, so this parabola, notice that it matches right at 0. Okay, that's the center of our convergence. And as it mimics that graph, it follows that graph fairly closely up until we get to about -1 and +1. Okay, and it starts to diverge a little bit. But as we increase the number of terms of that polynomial series, so if we take a look at the cubic function in black here to the right, so this cubic function, notice that it is fitting that red exponential function even better than on the left when we had the quadratic. And we can do this infinitely. We can make this a 4th degree polynomial, a 5th degree, and continue doing so. And as we add more terms, it's going to follow that exponential function closer and closer. We can also look at the sine function. So here I have the sine function in green, and in purple we have the cubic function that is following that sine function. Again, at 0, it is matching, and as we go away from 0, it starts to diverge. But as we add more terms, so if I make this into a 5th degree polynomial, to the right here, and in orange we have the 5th degree polynomial, we can see that it is more closely following the sine graph. And as we add the next term, which is a 7th degree polynomial, it's going to follow it even better. The next term, which is a 9th degree polynomial, it's going to follow it even better. And eventually, as we add infinite number of terms, it'll match this sine graph perfectly. For log x, we have the blue graph represents log x. Okay, so you can follow that blue graph like that. And we have the polynomial, the quadratic, in purple following it. And again, at the center, which is 1, it closely matches and it starts to diverge as we move away. But as we increase the number of terms, we go from a parabola to a cubic function on the right. You can see that the orange graph is following the log function even more closely. And that we can add more and more and more terms. This is actually, I think it's a 5th degree polynomial. We can't see the rest of those terms, but the 5th degree polynomial fits better than the parabola, and we add more terms, it'll fit better and better and better. And we have infinite number of terms that we can add to this.